on to square roots. You are probably pretty familiar with these concepts when we speak of a square root, but again, on the knowledge assessment, this is definitely one of the topics that is hit pretty hard. So we start off with the definition. We say if a squared is equal to b, then a is a square root of b. Right? Just to give you an example, we could say that 4 to the second equals 16. Right? We all agree to that. So what we're saying is this concept, a squared equals b, we're saying then 4 is a square root of 16. But what you have to keep in mind is that it's also true that negative 4 to the second is also positive 16. So you could say negative 4 is also a square root of 16. Now, that gets a little confusing because we become kind of lazy when we say the word square root when we're actually implying something else. And that's what this star is saying. Right? It says the non-negative value of a. So forget this one. The non-negative value is known as the principal square root. You can think of that as the positive square root of b and is written this way. So when we see this symbol, that symbol technically is not called the square root. It's called the principal square root. Because otherwise, if we're just saying it's a square root, we'll always get two answers. Well, most always get two answers because every positive number has two square roots. One positive, one negative. If I just said, hey, what's the square root of 25? The answer is, well, 5 or negative 5. Now, that is totally different than me putting that little check mark symbol and putting the 25 inside. Now that's saying, no, just give me the principal square root of 25. Now, saying principal square root every time is kind of annoying, so we get kind of lazy and we just say the square root of 25. Everybody knows what we're talking about. That's what we're talking about. Well, we still have to be kind of careful. So we're asking for the positive square root of 25, and the answer is just 5. Right? And that's what we're showing down here. Okay, now this number that we write underneath, this b value or this 25, that's what we call the dividend. Or not the dividend, the radicand. Oh my goodness. Radicand. Because a lot of times this is called a radical symbol, but we've got to be careful again. That's lazy language. We'll just say that the number that we're taking the square root of, that's known as the radicand. Right? So all we have to do is think, okay, what number times itself that's positive gives us this radicand, and that's what a square root is. So as we look at some examples here, the radicand is 36. I'm asking what is the positive square root of 36, or let's just say the square root now refers to positive, so we can be lazy with the language. What's the positive square root of 36, or what's the square root of 36? What number times itself is 36? That's positive. The answer is 6. Notice you don't say 6 or negative 6. This is the positive square root only. Okay, now looking at a problem like this, this says 5 times the positive square root of 81. So 5 times the positive square root of 81. It's 5 times 9, which is 45. Right? That's what that would simplify to. Here, this plus or minus 7, well, it's saying positive or negative 7 multiplied to the positive square root of 9. Positive square root of 9 is 3. So positive or negative 7 times a positive 3, well, your answer is going to be positive or negative 21. It's either going to be positive 21 or negative 21, depending on what 7 is, positive or negative. You know, with fractions, it's not that these are more complicated. They're really not. We're just going to use a simple rule with square roots. We can split up square roots, numerator and denominator of a fraction. So instead of thinking this as the square root of the fraction 25/4, think of it as the square root of 25 divided by the square root of 4, and that makes the problem a whole lot easier. So the square root of 25, or the principal square root of 25, is 5. Principal square root of 4 is 2. We'll call our final answer 5/2. Right? Now, that's when the problems come out nice. I picked the radicands each and every time here that turned out to be perfect squares. 36 is a perfect square. 81, perfect square. 9, 25, 4. Those are all perfect squares. And when you take square roots of perfect squares, well, life is pretty easy. However, when you take square roots of non-perfect squares, it gets a little bit more challenging. We have to simplify these. Now, what we're not looking for is going to the calculator and saying, okay, well, my calculator has a square root button. I'll just do the square root of 32 on my calculator, and this is the answer he's looking for. 5.65, 7 roughly? That is definitely not the answer we're looking for when we say simplify. Simplify means give me the exact value of this in a simpler form. What that is on the calculator is an approximate. Even if you use all 9 decimals on your calculator, it's still an approximate value. It's not exact. However, what we need to do is we need to rewrite square root of 32 in its simplest form. Right? That is the exact same value as the square root of 32, not rounded to 3 decimals or 4 decimals or 20 decimals. Because when you take the square root of a number that's not a perfect square, you're going to get a pretty messy number. It's called an irrational number. Right? And we're not looking for rounding here. We're looking for the simplest version that's still exactly the same. Right? So what we have to do is kind of extract the perfect square factor in this 32. So our radicand is 32. What I'm looking for, what is the largest perfect square that divides into 32? Again, let's get our list of perfect squares. So we could say for positive perfect squares, 1, 4, 9, 16, 25, 36, 36, 49. The list is endless. We're looking for the largest positive perfect square that divides into 32. Right? So as far as those numbers are concerned, the largest positive would be 16. Largest positive perfect square that divides into 32 is 16. So now we're going to take advantage of a multiplication rule. Just like with division, you can split this up top and bottom. We can do the same with multiplication, and we will. But first, let's rewrite our radicand. 32 we can write as a perfect square 16 times whatever it takes, 2. 16 times 2 is 32. So it's not like I'm just picking 2 numbers. You know, someone will say, well, what's wrong with 8 and 4? Well, 4 is not the largest perfect square, and 8's not a perfect square at all. So we're always looking for the largest perfect square. So largest perfect square for our radicand. So once you do that, now we're going to use the multiplication rule. Just like we can split up division, numerator and denominator, we can split this up into the square root of 16 multiplied to the square root of 2. We split it up individually into the factors of our radicand. Right? And once we write it this way, we can definitely clean up the square root of 16. We'll call it 4. Square root of 2, nothing you can do about that. This is the simplified version of the square root of 32. We call it 4 square root of 2, which is the simplified version, like I said, of the square root of 32, as opposed to what we had on our calculator. Right? This number here, that's the approximate square root of 32. And if I type in 4 square root of 2, notice they're the exact same answer. But 4 square root of 2 is what we call the simplified version. So we're not going to decimals. We go to decimals when they say approximate these values or round to the nearest 10th, 100th, 1000th, whatever. That's when you can go to your calculator and get those decimals. But when they say simplify, they're looking for the exact value. 4 square root of 2 is exactly the same as the square root of 32. Decimal for decimal. Okay, so negative 7 square root of 48, same thing. 48 is not a perfect square. What to do with the negative 7? We'll just attach it. So it's negative 7 times the square root. Largest perfect square that divides into 48. Again, 4 does, but 16 is even bigger. So you're looking for the largest. This is 16 times 3. Right. So we'll keep the negative 7 out there. We'll split these up into 2 square roots. Square root 16 times the square root of 3. We don't need the dot necessarily. And we'll say this is negative 7 multiplied to the positive square root of 16, which is 4, multiplied to final answer is negative 7 times 4, which we'll call negative 28, times the square root of 3. And you can see, like I said, on a calculator, you can easily go to that and check to make sure they do give us the same decimals. So if we go negative 7 square root 48 and negative 28 square root of 3. So that's both negative 7 square root of 48, which is not simplified, and negative 28 square root of 3, which is simplified. Notice they're the exact same answer, but negative 20 square root of 3, that's the simplified version. So watch it when they say simplify. They're not looking for a decimal approximation. Okay, last one. Plus or minus 10 square root of 27. Let's bring that down here. Okay, 27 unfortunately is not a perfect square, so the largest perfect square that divides into 27 would be 9. So we'll say the square root of 9, and 9 times 3 is 27. So we'll split these up. Call this plus or minus 10 square root 9 square root 3. Square root of 9 is just 3. So plus or minus 10 times 3 times the square root of 3. Final answer will be plus or minus 30 square root 3 is the simplified version of plus or minus 10 square root 27. All right, we'll see what else we can do with these square roots in the next video.